Hey guys, welcome back to my YouTube channel. I hope you all are doing well. So, before starting today's topic, if you are a newcomer to this channel, let me introduce myself. I am Karthik Agrawal, currently studying in Sri Venkateshwara College of Engineering. So, let's start today's topic. Today we are here to talk about duplication formula. So, let's dive in. The term duplication formula might refer to several concepts depending on the specific engineering discipline. However, one of the most common application of duplication formula is in structural engineering. In engineering, particularly in fields like electrical engineering, mechanical engineering, and civil engineering, the duplication formula is often used in integration to simplify complex integrals involving trigonometric functions. These formulas are derived from the double angle identities in trigonometry. They allow engineers to convert integrals involving power of sine or cosine into integrals involving powers of cosine with the double angle or vice versa, which can often simplify calculations. For example, if you have an integral involving sine square of x, you can use the duplication formula to rewrite it in terms of cos 2x and then proceed with integration, potentially make the process easier. We have also learned duplication formulas in a younger standards such as a plus b the whole square or a minus b the whole square, or similarly a plus b into a minus b. Those types are duplication formulas which often helps us to reduce the burden. Since now we are in engineering stream, we use duplication formulas in gamma or in beta functions. So now let's learn about beta and gamma functions. The beta and gamma functions are two important special functions in mathematics, often encountered in various fields of science and engineering, including statistics and signal processing. The beta function, commonly known as the first order Ural's integral, is a particular function linked to the gamma function and binomial coefficients. The gamma function is one of a group of functions that can be defined most easily using definite integrals. As you can see, I've given a formula for beta and gamma functions, that is beta of m comma n is equal to gamma of m into gamma of n whole divided by gamma of n plus n. So now let's see some important formulas of beta and gamma functions. As you can see, some important formulas of beta and gamma functions, that is gamma of 1 is equal to 1, or gamma of 1 by 2 is equal to root n. Similarly, you can see one more important formula, that is gamma of n. Gamma of n is equal to integral 0 to infinity x to power of n minus 1 into e to power of minus x dx for all positive integers. Similarly, one more formula of gamma function is gamma n plus 1 is equal to n gamma n, which is also equal to n factorial. And the next important formula is gamma 0 to pi by 2 sine to power of p theta into cos to power of q theta d theta is equal to gamma of p plus 1 by 2 into gamma of q plus 1 by 2 divided by 2 gamma p plus q plus 2 by 2. I have shown you all the important formulas of beta and gamma functions which may come in exam. So let's see some derivations of this formula. Now let's see to the first derivation, that is to prove beta of m comma n is equal to 2 integral 0 to pi by 2 sine theta 2m minus 1 into cos theta to power of 2n minus 1 d theta. So let's see the derivation of this. Since we know that beta m comma n is equal to integral 0 to 1 x to power of m minus 1 into 1 minus x to power of n minus 1 dx. So this we have learnt in previous classes, that is, let x be sine square theta. Now doing partial differentiation of x, we get dx is equal to 2 sine theta cos theta d theta. Since we know it's a definite integral, so the integral values must change. So when x is equal to 0, theta is equal to 0, and when x is equal to 1, theta is equal to pi by 2. Hence now the beta function will be beta of m comma n is equal to integral 0 to pi by 2 sine square theta m minus 1 into 1 minus sine square theta of the power of n minus 1 into 2 sine theta cos theta. Let's take 2 common out since it's a constant. Therefore, 2 integral 0 to pi by 2 sine theta to power of 2m minus 2 into cos theta to power of 2n minus 2 sine theta cos theta d theta. Afterwards, we split the powers of sine theta and cos theta. Then after this, we'll get the final formula as beta m comma n, that is 2 integral 0 to pi by 2 sine theta to power of 2m minus 1 into cos theta to power of 2n minus 1 d theta. It's a bit tricky, so I would recommend you all to practice it twice or thrice. Then you all may understand this derivation. Now let's move on to the next derivation, that is to prove beta of m comma n is equal to beta of n comma m. This is one of the most asked questions in exam. So let's see this derivation. We know by the definition of beta function, that is beta of m comma n is equal to integral 0 to 1 x to power of m minus 1 into 1 minus x into power of n minus 1 dx. Now we use the basic principle of definite integrals, that is integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. This we have learned in our 12th standards. I hope you all remember this basic principle of definite integrals. So using this principle, the above equation we get is beta m comma n is equal to integral 0 to 1 in 1 minus x into power of m minus 1 into 1 minus of 1 minus x to power of n minus 1 dx. Hence we get the above equation as integral 0 to 1 x to power of n minus 1 into 1 minus x to the power of m minus 1 dx. The formula is beta of m comma n is equal to beta of n comma m. There are many other derivations of duplication formula in integration, but for now I would like to do these two derivations only. Now let's go and see one example sum of this. So here is the question, that is find the gamma of 5 by 2 into beta of 3 by 2 comma 1. So let's start with the sum. We know that beta of m comma n is equal to gamma of m into gamma of n divided by gamma of m plus 1. That same step we have done here. So the whole equation will be gamma of 5 by 2 into gamma of 3 by 2 into gamma of 1 whole divided by gamma of 5 by 2. Since we know that gamma of 1 is nothing but 1, and from the numerator and denominator we would cancel gamma of 5 by 2, hence the whole equation will be gamma of 3 by 2. And now we use the formula gamma of n is equal to n minus 1 into gamma of n minus 1. Same formula we have used, and we'll get the equation as 3 by 2 minus 1 into gamma of 3 by 2 minus 1, and we'll get the next step as 1 by 2 gamma of 1 by 2. We also earlier discussed that gamma of 1 by 2 is nothing but root pi, hence we'll get the final answer as root pi by 2. So I hope you all have understood this sum. There are many other sums about this. I would recommend you all to practice few sums so that you would not feel these duplication formula that are used in integration to be difficult. Thank you for watching this video. I hope you all have learned something about duplication formulas. So if you all have liked this video, don't forget to hit that subscribe button and like this video.